Hello, and welcome to this Smith's Interconnect webinar. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the Speaker Bio window, with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenters. With us today we have Gregory Kay. Gregory is a Global Product Line Manager at Smith's Interconnect. And joining us in the Q&A session today will be John Anderson. John is the Principal Engineer at Smith's Interconnect. To read more about either of the presenters today, please look at the Speaker Bio window right next to the main presentation window. And with that, I'd like to pass things along to Gregory to get this webinar started. So Gregory, go right ahead.
Thanks, Katie. Welcome everyone to today's webinar on high power interconnect. Today's agenda, we'll be discussing high power applications and growth for the future. We'll then be discovering the Hyperboloid contact technology, and then we'll learn a little bit more about the HBB product series, which is offered by Smith's Interconnect. So we'll start off with high power applications and their growth for the future. But before I dive into the details around high power applications, I wanted to ask you all a question. Where do you see the biggest potential growth in high power technology? So go ahead and select one of the options here, and we'll start to see the answers come through. We've got various different options for you. So automotive, defense, aerospace, industrial, and other. So go ahead and select where you feel the biggest potential for growth in high power technology is. Trying to see some answers coming through. All right. Okay, so last chance to get your answers through before I move on to the result. Okay, so let's take a look at the results. Right, as expected, automotive is really a high scorer. So you can see automotive in everyday life, especially growth in high power. That's certainly the most visible market for high power technology and growth. We can see really good growth in defense, aerospace, and industrial, or what you guys feel is growth in defense, aerospace, and industrial. So I'll cover in a couple of slides a really interesting fact about the differences between automotive, high power technologies, and defense and aerospace. So Smith's Interconnect is catering to all of these markets, but they're being catered to quite differently. So that's why we're covering defense and aerospace today, even though it may not be the area for high power that's the highest growth, but it needs to be catered to separately. So with that, we'll move into electrification of combat vehicles, which is a really exciting area for growth. And we'll start with a few quotes here. So these are 4 quotes from military personnel. The top 2 happen to be from the UK and the bottom from the US. Electrification is a win-win for the Army as it enables operational advantage, reduces logistic demand, and puts the Army on the path to meeting net zero 2050 sustainability objectives. What Brigadier Matthew Cansdale is saying here is that not only are we required to move forward in electrification in combat vehicles due to the sustainability objectives, it actually gives us an advantage, both logistically and operationally. So it's a real win-win. Delivering effect needs the right power in the right place at the right time. Using hybrid vehicles will make it easier to get power where it needs to be. What Colonel Simon Ridgway is saying here is a really interesting point about the path towards electrification. So hybrid vehicles is certainly the first step, but also moving towards electric powered drivetrains can change the landscape of the combat arena. By using hybrid vehicles and ultimately fully electric vehicles to power things like field hospitals and communication centers, we're able to change the landscape and change what we do with combat vehicles. Down at the bottom, while there are certainly some similarities in commercial and military requirements, we're mindful that the Army faces unique operational challenges compared to those in the commercial market, and silent watch and off-road usage would typically use twice the energy of an equivalent commercial vehicle. What these couple of quotes are saying is similar to what I touched on before, which is that the developments in automotive, whilst have similarity to the developments needed in combat vehicles, there are differences and they need to be treated differently because the requirements don't necessarily match up. So moving into what is going on in the arena of electrification of combat vehicles. So global efforts are well underway to moving towards hybrid and all-electric combat vehicles, and that's being driven by the increasing pressure to meet emission targets and to future-proof the fleet. Current design and prototyping activities are opening up really significant design-in opportunities for manufacturers of high-power components. It's a really good time to get on board. Some of the key milestones in electrification of combat vehicles. In the non-tactical vehicle market, there are almost 250,000 non-tactical vehicles in the US Army alone. That's just the Army, not the military in total, and that's just the US. So the global number of non-tactical vehicles is very high. The big milestones to meet in non-tactical vehicles is conversion to hybrid and then ultimately fully electric vehicles, and then building infrastructure to charge and maintain those fleets. I'm sure you'll all remember when electric cars started appearing on the market, one of the big questions was, how are we going to build the infrastructure needed to charge and to maintain the cars? The combat vehicles will face a very similar challenge, different, but still the same challenge around infrastructure, and that's something that we need to hit on a milestone standpoint. On the combat vehicle side, conversion of existing platforms to hybrid drives, a big milestone, and then eventually development of fully electric combat vehicles. Lastly, leveraging the new electric fleet to change the combat landscape, similar to what we touched on before. A quick story here. During the Industrial Revolution, generally, big factories had a fossil fuel engine right at the center of the factory and a large drive shaft that ran through the full factory. Where you needed power, you would tap mechanical rotational power off that drive shaft with smaller drive shaft, and that's how you would power the factory. When electric motors started becoming commercially viable, there was the hypothesis that production and efficiency would increase if we switched from fossil fuels to electric motors. But that didn't happen. When people changed from fossil fuels to electric motors, generally productivity stayed the same. It wasn't until we started looking at the electric motor differently to the fossil fuel motor, that's when the real productivity increased. So what they did was they dropped in large electric motors in exact replacements for the fossil fuel motors with a big drive shaft running through the factory and then smaller drive shafts tapping that energy off. It wasn't until they used smaller motors dotted around the factory and using motors next to where the power was required that they got that productivity increase. The exact same thing will happen with combat vehicles. If we just directly drop in an electric motor in place of an internal combustion engine, we will get some advantages, but we won't fully leverage the advantages of electrification until we change our view on what an electric vehicle can be. So here's some examples of ongoing activities in electrification of combat vehicles. The US Army has the power transfer cohort, which is primarily around the non-tactical vehicles and converting those to electric, with rapid recharging for Army EVs, transportational power, scalable infrastructure, and integration of the new EV infrastructure into the Army's existing infrastructure. On the hybrid electric drive, there's a lot going on. BAE has been partnering with Kinetic on a hybrid electric drive for the Bradley fighting vehicle. And the UK MOD has been doing something similar with their hybrid prototypes of their existing combat vehicles like the Foxhound and the Jackal. So a lot going on in general in the electrification of combat vehicles, really exciting market and something that we're seeing a huge growth in. Similarly, electrification in aerospace is a really exciting area, also an area of enormous growth. It's being yielded as the third era of aviation, and we're seeing a real urgent shift in aerospace away from fossil fuels. Within the aerospace community, it's really seen as that urgent shift. You could be forgiven for thinking that it's something far off into the future, but within the aerospace community, it's really seen as an urgent shift. And the shift is really being driven by the high fuel costs and by meeting noise and carbon emission regulations. All electric and hybrid electric aircraft reduce noise, increase efficiency, and allow an entirely new approach to aircraft design, similarly to what we were talking about with combat vehicles. For example, we're seeing a whole new market of urban air mobility open up, which could only be possible through electrification of the aerospace vehicles. On the right-hand side, you can see a number of different examples of how we might power aircraft through hybrid options. In the bottom right, you have the all-electric option, which is the end game. But whilst we get there and whilst we wait for battery technology to develop, we'll see some of these other hybrid options take place on the market. Just like we saw with combat vehicles, here's some examples of what's going on in electrification of aerospace. So urban air mobility is something we're seeing more and more of. It's small, light electric aircraft with short range within an urban travel area. Generally, they're highly automated to avoid pilot error in built-up areas, and they usually feature VTOL or vertical takeoff and landing to avoid the need for a runway in a built-up area. There are a very large number of UAM startups, but there are established players in the market as well, like Airbus and Rolls-Royce. You can see there below the City Airbus, which has already undergone a untethered test flight. So we're seeing the developments coming in thick and fast. Generally, in UAM, we'll see the need for small, lightweight, high-power components, generally at high volume and generally quite price-sensitive. With the longer-range aircraft, the use of a hybrid electric drive to increase efficiency and reduce emissions is already being seen. And then development of fully electric longer-range aircraft is initially starting with light aircraft, but as battery technology increases, we'll see that move to larger aircraft. In the longer-range aircraft market, we'll see high-power, high-altitude components required, generally at lower volumes and a little bit less price-sensitive than UAM. So that's generally the market that we see a lot of growth in, the combat vehicle, the electric aircraft market as well. So how do we see within Smith's Interconnect, how do we face the challenges that are met in those markets? We're generally doing that with the Hyperboloid contact technology, and I'll talk a little bit about that now. But before I delve into the details of the Hyperboloid, I've got a second question for you. How familiar are you with the Hypertac Hyperboloid contact technology? This is an easy question, no wrong answers, so please go ahead and select one of the options here. Never heard of it, basic knowledge, good understanding, or an expert. Maybe if a lot of experts come through, you can take over from me and talk a little bit about Hyperboloid. So go ahead, enter in one of the four options now. Okay, starting to see some results coming through. Okay, last chance to give a click. Excellent. Okay, I'll move forward and see the result. All right, good. We've got a few experts, but then generally split between never heard of it, basic knowledge, and good understanding. Well, I hope I do you all justice and talk through the Hyperboloid a little bit for each one of these different levels of knowledge, and hopefully you'll all take something away from it. Let's start with features and benefits of the Hyperboloid in general. So the Hyperboloid ranges from a really small signal connector like 0.4 millimeter socket all the way up to the really big high power connectors. And this is sort of features and benefits in general. They all have low insertion and extraction forces, long contact life, low contact resistance, high current ratings, and really good performance under shock and vibration. And those features lead to a number of benefits like high density interconnect systems, lower cost of ownership, lower power consumption and more efficient use of power, maximum contact and connector performance, and reliability under harsh environments. So these are, like I say, the more general features and benefits, but what does that mean for high power, high current applications? So the lower insertion force means that larger contacts, which you need for high power applications, can be connected and disconnected without the need for special tools. The longer life means that high power performance remains stable throughout the life of the equipment. The low contact resistance means that electrical losses are minimized, temperature rise across the connector is minimized, and the critical battery life is efficiently used. High current capability is really intrinsic to the Hyperboloid contact and provides an increased connector performance, and shock and vibration immunity is critical for performance in the markets that we've been talking about. I did want to touch on a phenomenon called fretting performance or fretting corrosion. This is a phenomenon where a pin inside of a socket is vibrating in an environment like combat or aerospace, and we see interrupts develop as a result of this vibration. So here you can see a test that was carried out on a 0.6 millimeter socket. We compared the Hyperboloid to the stamped and fork and blade contact. You can see the standard stamp and the fork and blade contact survives around 250,000 cycles, whereas the Hyperboloid survived 18 million cycles. The Hyperboloid is really, really well suited for this sort of phenomenon, the fretting phenomenon, and it means that it survives in field far longer than the competitive contact. Generally, when we're talking about fretting performance, it manifests as interrupts and often as intermittent faults, which leads to your equipment being down for a long time as you're fault finding. So the Hyperboloid really offers a lot more security and performance in that sort of arena and can be really, really helpful for downtime of the equipment. The last criteria I wanted to talk about with the Hyperboloid is its design adaptability. There are a number of different criteria that we can vary that tailors the Hyperboloid to the specific end requirement. So the number of socket wires, how thick they are, the wire length, the angle, and the tension, all could be adjusted and all can be biased towards various different criteria. So for example, they could be biased towards high mating cycles, high endurance, or just towards pure electric conductivity. So it's a very, very adaptable contact technology. Some of the typical values against industry equivalents, you can see about a 10-fold on mating cycles, 5,000 versus 500. The contact resistance is much lower at 28 to 38 microohms versus 85 to 114. And then the power loss, again, much lower, 8 watts to 25 watts. And this means that the contact itself and the connector as a whole needs to deal with less temperature that it needs to get rid of because of losses of power. But also, if you're running a battery in a vehicle, it means that you're using less of that battery capacity towards waste. It's a really, really important criteria. Okay, so now let's look at some of the examples of the Hyperboloid in use. So this is a military hybrid electric vehicle battery connector. It's a 2-pole connector with a safety interlock. It's rated at higher than a kiloamp of current and lower than 10 microohms of contact resistance. It's a blind mate connector that connects the battery to a chassis or rack and panel, and it provides a very reliable, stable interconnect that enables a rapid battery installation and replacement. You may remember when electric cars first came onto the market, one of the challenges was charging time, and one of the solutions that was proposed was replacing the battery with a fully recharged battery at charging stations. That didn't really pan out in the automotive industry, but in the military industry, it may very well be the way that they conquer high charging times, and this connector is perfectly suited for that sort of application. Another example of the use of Hyperboloid is the single pole high current interconnect on the screen. This is a quick connect and disconnect connector. It shares the quick latching mechanism with the HBB, which I'll touch on in detail in a minute. It's again rated to higher than 1 kiloamp and is designed for a cable or flexi bus bar to panel or box application, again providing a very reliable, easy to use and stable interconnect system. So like I say, I'll delve in a little bit more into the HBB product series, but before I do that, I have one last question for you. So what are your key design considerations when selecting high power interconnect? For this one, you can select more than one or all of them if you wish. But what's important to you when you're thinking about high power interconnect? So go ahead and select as many or as few of these as you want. It's electrical performance, ease of use, size, weight, and safety. I'll give you a second to select some of yours. Okay, starting to see some results coming in now. Okay, last chance to submit your answers. Excellent. Okay, let's have a look. All right, so electrical performance is certainly the most important, and then size, ease of use and safety are about equal, and then weight. Okay, great, great results there. When designing the HBB, actually all 5 of these are really, really important through the design process of the HBB, and we really threaded the needle of trying to balance between these 5 things to get the ultimate interconnect for high power applications. So let's talk about the HBB for a minute. These are a couple of animations that I'm going to take you through to just sort of give you a feel of what the HBB is. The one on the left, which is the animation we'll go through first, is the single pole. So here you'll see a straight back-shelled receptacle and a right-angle back-shelled plug. Inside is the single pole Hyperboloid. This comes in both 350 amp and 500 amp versions. And you can see there the Hyperboloid is in the receptacle, but it is a fully gender reversible connector. The next connector on the right-hand side is the 5-pole connector, and that's featuring a straight back shell on the plug. Here you can see the quick latch mechanism, which is featured on both the single pole and the 5-pole. Here you can see the 560 amp Hyperboloid contact, and in the center of that ring of 5 contacts is 2 safety interlocks. So here, just keep an eye on the outer collar on the plug. As it mates, it will move out of the way. It is a push to mate connector, so it rotates itself and then clicks in place. And then as you can see, you just rotate the collar to unlatch and then pull it off. So that's the single pole and the 5-pole. But here's a bit of a product summary. The HBB handles high current in small size with exceptional performance in harsh environment. The single pole comes in a size 17 350 amp version and a size 21 500 amp version. The 5-pole has 5 60 amp power and the 2 safety interlocks, all within the same size 21 shell as the 500 amp single pole version. They were all designed for a whole wide range of high power applications, but they're particularly suitable for electric drives in fighting vehicles, unmanned vehicles, and a whole host of industrial applications as well. So we'll just work through some of the features and benefits of the single pole and the 5-pole. So as I mentioned, the single pole comes in 350 and 500 amp versions. The 5-pole has the 560 amp power contact and the 2 high voltage interlocks. They both have 5,000 mating cycles, both have low contact resistance and really good shock and vibration immunity. They're both gender reversible and polarized. They both have minimum component count and feature the same quick latch mechanism. The quick latch mechanism is really advantageous for ease of use, but also really important for safety and for panel spacing. So when using a threaded latch mechanism, you have to space the connectors further apart to get a gloved hand in between the connectors to thread and unthread. With the Hyperboloid, with the HBB quick latch mechanism, it's far easier and you don't have to have the same space around the connector. I highly encourage everyone to take a look at the white papers that you have access to. The white paper takes you through in more detail that panel spacing with a direct comparison to a threaded connector. So take a look at that and you'll see a little bit more detail around what I'm talking about here. Both the 5-pole and the single pole are ideal for harsh environment conditions, both with 360-degree EMI and RFI shielding, and they're both sealed to IPX7 and IP6K9K when mated. They both have cable and panel mount variants, and both ergonomic and low weight design. So a lot of commonality between the single pole and the 5-pole, but a great family of connectors with applications for high power. Here is the electrical performance and mechanical performance of the single pole and the 5-pole. I'm not going to go ahead and read out all the criteria. This is really just for you to have a look at to see some of the typical performance criteria of these connectors. Please do go ahead and look at the catalog. It's got all of this in more detail and may very well just color your understanding of how these connectors perform. So that's what I had on the HBB. And actually, now I'm going to move to a summary of what I've spoken about so far, and then we'll move to Q&A. So what we've spoken about so far is the exciting development in growth of electrification of combat vehicles and aerospace vehicles that require a really unique solution and unique challenges. The hyperboloid contact is very well positioned to cater to those challenges, and Smith's Interconnect connectors like the HBB combine both the hyperboloid contact and intelligent connector design to solve both the new and the existing high power challenges. The topics we discussed today was high power applications both for the future, hyperboloid contact technology, and the HBB product series. So with that, I'll hand over to Katie to walk us through the Q&A.
All right, Gregory, thank you so much for that great presentation. We are going to move into taking some of the questions from our attendees. So if you have a question today, you can go ahead and place it into the Q&A window and click submit. We will do our best to answer as many questions as we can. If for some reason you do not hear your question being answered, we will reach out to you following today's webinar. And as Gregory mentioned, if you wanted to take a couple of the items with you today, we have a lot of items listed right in the resource widget that is right below the presentation window. If you click on them, they will download to your computer, so you're able to take those with you today. All right, so Gregory, our first question today. Can you explain a little more about how the safety interlock works on the 5-pole HBB?
Yeah, sure, I'd be happy to. Okay, so you can see actually the image on the screen. You can see the 5 contacts which handle the power, and then the 2 safety interlocks in the center. They're both hyperboloid contacts. And the reason that there are 2 is so that it enables the customer to send a signal down one of the lines, loop that, and then send it back to their control center. What that does is it means that it can sense any interrupt in those contacts and shut off power. So the way that the contacts are situated in the connector, it means they're the last thing to mate and the first thing to break when you disconnect the connector. So as soon as you start disconnecting the connector, the customer will be able to register that as a disconnect and interrupt the power. Now, of course, if you have a system where you've got a long line where you have a control center on either end, you don't necessarily need to loop that, but because there are 2 contacts, we have the ability to loop that signal back.
Okay, Gregory, thank you so much for that answer. All right, another one here on the topic of Hyperboloid. What material is the socket made from?
Thanks. Okay, good question. So the Hyperboloid is made of wires, generally a copper alloy wire, and they are gold-plated. And the reason for that is increased electrical performance through both the copper and the gold plating, and also a great corrosion resistance as well. So the materials are a big part of why the Hyperboloid is as high-performing as it is. We use very high-performing materials in order to reach the performance criteria that we walked through today.
All right, great. Thank you so much for that answer. So as I mentioned before, there are some items in our resource widget if you'd like to take that with you. We also have a survey that's listed on the bottom of your webinar console. If you want to fill out the survey now, feel free. It's also going to pop onto your screen at the end of this webinar, and your information and feedback is always important to us. So please take a moment to fill that out when you can. A reminder, if you have a question today, you can fill it into the Q&A window and click Submit, and we will do our best to get through as many as we can. So next question here. On the 5 poll, you mentioned that each contact handles 60 amps. Does that mean it is rated to 300 amps overall, or is it derated when all the contacts are loaded?
Okay, great question. John, do you want to handle that question?
Yes, I do, yes. Yeah, all contacts are rated 60 amps. They can all carry that current simultaneously. Where you would have to be a little bit more careful would probably be in a cable harness where your cable type would then become a factor. But in terms of the connector, it can handle the full current, maximum rated current as specified.
Thanks, John.
Okay, great. Thank you, John, for that answer. So as I mentioned, if you have a question, go ahead and enter it into the Q&A window and click Submit, and we will do our best to answer it today. All right, let me just take a second to dig through the questions here. Okay, we have one here. Do you see the Hyperboloid technology being used in low-voltage micro-pin applications?
Yeah, so we do see, as I mentioned earlier on one of the slides, there's a very wide range of Hyperboloid sizes. They go down to really quite small at 0.4 millimeter pins, and we do see that for signal. So with high power, you'll see obviously the much larger Hyperboloid, but we do see applications throughout the ranges, with obviously the smaller ones being for signal rather than for power.
Okay, great, Gregory. Thank you so much for that answer. Another person here is asking, how long has this technology been in use?
John, do you want to take that one?
Yeah. So, approximately the Hyperboloid contact technology is actually fairly mature. It's been around for over 40, maybe 50 years. So, particularly in the smaller contact sizes, the signal contacts, it's certainly been around for 40 to 50 years. The power stuff has evolved and is becoming more common in more recent times. That's all I would add to that, really. But yeah, Hyperboloid in general, been around for decades.
Thanks, John.
All right, John, thank you so much for that answer. So as of right now, we don't have any more questions from the attendees, but I am going to give you all another minute or two to ask any questions that you may have. So while I wait for you to submit any last-minute questions, just a reminder that this webinar will be on demand for the next 90 days. If you'd like to come back and watch this again, feel free. You can use the link from the email today, or you can use the link from an email that we are going to send out to you tomorrow. So again, that will be available 90 days. You can always come back and watch us again. And if you think of a question later on, you can also ask it anytime during that on-demand period. So I'll give you another minute or two to ask any last-minute questions that you guys might have. And just a reminder, if you want to take any of the items with you today, go ahead and click on those right from the resource widget. They will download onto your computer. You can take those on your way out. There's some great information in there for you. And I'll just give you another minute or two to ask any questions. All right, guys, it looks like that's all the questions we're going to get in today. Unless anyone has a last-minute question, we are going to start to wrap the webinar up. So, gentlemen, I want to say a huge thank you to both of you. Gregory, for such a great presentation. John, for joining us for the Q&A. Thank you both so much. It was a pleasure.
Thanks very much, Katie, and thanks, everyone, for attending.
All right. Thank you guys both. And a huge thank you to our audience members for being part of this event. As I mentioned, you're going to receive an email from us with a link to the on-demand version of the presentation. You are going to be able to come back and watch us again over the next 90 days, and you can even share it with colleagues. And as I mentioned, that survey is going to pop up on your screen. If you have a moment to fill out that survey, we would love it. For anyone watching this on demand, you're going to find that survey located along the bottom of your attendee console in the survey widget. And one more time, grab those resources on your way out today. So a huge thank you to everybody for taking time to attend this webinar event. Take care, and we will speak with all of you soon.